As many of you know, with the release of Data Hub WebView 1.4 comes a very powerful feature called dynamic point binding. And I recently had a request from one of our customers to show them how to use the combination of S# scripting in WebView with dynamic point bindings to create a composite control template. And in this video blog, that's what I want to demonstrate, how we can use a number of different controls grouped together to form a composite control, and then how we can use that as a template for multiple instances of the control. So you'll notice that, for example, right now in this page that I've developed, we have three different composite controls. We've got one that's pointing to a wind turbine A1, wind turbine A2, and wind turbine A3. And each of these groups, or each of these composite controls, actually have about 10 different point bindings. You can see that the gauge is bound to PV. I also have labels for SP, PV, and MV, and I've got set point data down here. And I also have a trend reflecting, again, those same three data points. And you'll notice that the trend data is different for each of these data points because, of course, the data is different. It's bound to different wind turbines. And of course, if I wanted to change the binding for these data points, traditionally what I would need to do is change each point individually. And of course, that's more work than we'd like to do. So in this video, I'm going to show you how we can use a composite control and some script to bind all those together. So I'm going to start by going back to design mode here, and we'll just start by creating a brand new page, and I'm going to remove the background image for that page. And so on this page, I'm going to start by actually just adding a couple different labels. So there's one and a second label, and I'll arbitrarily add one of the gauges to our page. Let me just zoom in a little bit on that. And I'm going to bind these two labels to the set point of my wind turbine A1. So right there. And I'm going to display, rather than the data value, the actual data domain, and I'll use the same binding on this guy, WTA1.sp, and I'll format that with a few different decimal points, and the gauge is going to be bound to WTA1.pv. Okay, and so I can see that my gauge is working just fine, and I've got this data bound to SP. And I'm going to group those together to form, in essence, a composite control, which can be copied, moved around, etc. And the key thing to understand, of course, is that if I wanted to copy this control, and I wanted, for example, this second one here to point to WT or wind turbine A2, I would need to change this binding, and I would need to change that binding, and I would need to change that binding. And again, that's more work than I really want to have to do. I'd like to find a way to just change all of the point bindings dynamically from WTA1 to WTA2. So to do that, I've actually prepared some script, S# script, which I'll make available to anybody who wants it here. Not sure how we're going to do that, but we'll figure it out later. And so you'll notice that in this script file, I've actually created 4 different script functions. And I'm just going to review a few of them here for you. You'll notice that this first script function here, get outermost parent, is simply taking as an input argument a reference to some control or some element on the page. It's then determining whether or not that element has a parent. In the context of WebView, a parent is like a container, or if you will, in this case, a group. So for us, the group is the parent for each of those controls. And all this code is doing is enumerating the element's parent and keep and it's going to keep checking to see if that parent has another parent, and it will keep doing that until there is no more parent, and then it returns. So in essence, if I had a group within a group within a group, and then several elements within that, this is just simply giving me the outermost group. Okay, so that's that first function. The second function is going to be referring to the outermost parent's tag, and in particular the tag indexed by that value there. So this is a very simple call. It's going to reference the outermost parent, and then it's going to use the getAllTags function to determine what the tags are for that parent. And let me just jump over for a second now to make sure that we understand where these functions like getAllTags and back up in this function pageElementParent, where they're coming from. Well, back in DataHub WebView, we can check our online help, and that's going to allow me to then say I want help on DataHub WebView scripting, and I'll click this link here as well, and then it gives me a very comprehensive online reference for a bunch of different elements that are available. And so I'm going to go down to, what do I want here? This one, controls namespace, and I can see here is the iPageElement interface as an example, and within that I can see there are several different members, and so one of the properties for any page element is something called pageElementParent, which is nothing more than the element's parent. I also see that for any page element, I can also say getAllTags, which is simply a function that returns a list of strings that represent the tags for that element. Now, that is not a industrial process variable tag. What we mean by a tag in the context of WebView is this property down here, tags. Tags exist for all controls within WebView, and they are a comma or space delimited list of identifiers used to logically categorize controls. In this case, for example, what I could choose to do is say there are a couple different tags that I want to keep track of for this group. I want it to represent the Canventus domain and the wind turbine A1. So if I were to go back up to this data point, you'll notice that right now it's in the Canventus domain. There's my WTA1 and there's SP. Well, what I want to be able to do is simply capture that information down here in the tags property, and I'm just choosing the tags property arbitrarily as a place to hold that information. But I just wanted you to see that all of the online help, all of the online help associated with the S# scripting is again available online here. And in this particular case, I'm using the pageElementParent property of an element and the getAllTags method. Okay, so let me just go back here to my WebView page. So the next thing I want to do is recognize that these points are using static bindings. And just in passing here, you'll notice that when I click on the group, it selects the entire group. But I can press the Control key once, and then I can select the individual controls in the group, just to make it a little bit easier to select items. And so rather than using a static reference to this point, what I want to use instead is one of my script functions, and I've already reviewed two of them for you, getOutermostParent and getOutermostParent tag. Well, the third function to review is one that I've called getRelevantPointName. This function expects an element and a subpoint, and so you can see all it's doing is it's saying get me the first tag, or if you will, the 0th tag. We've used Canventus for that. And get me the first tag, the 1 tag, and that was WTA1. And all it's doing is constructing a string where this will become Canventus WTA1 period SP or PV or MV. So that's really the function that I want to use here. So let's go back to this guy, and I'm going to say equals get relevant point name, and I'm going to pass the element that this script is owned by. This element, of course, is right now the label. So element in this case is that text label, and then I'm going to say I would like to use the partial point name of SP. And you can see that the script engine has already interpreted this function, and here's the result of that, conventus :wta1.sp. And I want to use the same function for this point here. Remember that dynamic point names all begin with the equal sign. And then for this gauge, I don't want SP, I want PV. And again, you can see that the function has been evaluated. So at this point, we really have not seen any change. We're still pointing to SP, SP, and PV. Of course, the difference is that we're pointing to those indirectly. We can see that the point binding is conventus WTA1.PV, but it's being derived from script. So that would allow us to now modify the tags in the script and hopefully change those bindings. There's a bit of a trick to it here, because you'll notice that when in fact we come down to this group and we change our tags from WTA1 to WTA2, nothing happens. This is still pointing to A1 because these functions haven't figured out that the tags property has changed. So we do need to make some modifications, and maybe I'll find a better way to do this in the next version of WebView. But for now, that allows me to recognize that I need to update these point bindings. I somehow have to tell them to go recalculate. So I'm going to choose to do that by adding a script binding to this tooltip text, and it can be put anywhere. I'm not actually going to use the tooltip text, but it allows me a convenient place to just put that script. So the first thing I want to do is tell the script engine that whenever the tags property of this control changes, it needs to reevaluate this script expression. And whenever you use a getP function and you reference a property, that is a signal not only to get the property of the tags, but it's a signal to script to say this is dependent upon that property. And so if tags ever changes, this script expression will be updated. And what I really want to do is to force a binding reset for all child elements of this element. Remember that this element references the owning object. And I'm just going to jump back to our documentation here for a second and show you that the intrinsic objects, there are several different intrinsic objects within the script environment. And you can see that element is the one I'm referencing here. Element references the actual page element that owns the script. So in this case, this script here is associated with the tooltip text property of group 1. So element in this case actually references group 1. And this function, force binding reset for all child elements, is really just over here. It's the fourth function. And you can see that it is expecting a parent element, and it's going to then enumerate the children of that element. And it's going to look at all parameters for each child. If it's a point binding, it's going to temporarily reset the point binding to none and back to point. Or if it's script, to script and back again, from none to script and back. And then it's going to make the same call on all of its children. So recursively, this function will reset point and script bindings for all children and grandchildren and great-grandchildren of this element. And it's going to automatically re-execute whenever the tags property changes. I'm going to start right now. Let me just scroll up again here. I'm going to force an update right now. So you'll notice that when I now come back to my, come back to here. Now when I change this, automatically I can see my set point and my gauge change. And I'll do that again. Okay? And so when I go back to the page that I had previously opened, let me just go back to my Canventus WT template. This is the one that I was showing you before. You'll notice that right now this group does not have a property inside tags. That's okay, and that's why these are erroring out. But if I look at any of these controls, so for example, here's my trend chart. You can see that my trend chart is actually bound to get relevant point name element MV. So I've updated this example to use those same script components that I was using previously. Of course, the difference is that when I now come down to my tags area and I use Canventus WTA1 and I hit enter, my chart, my set point, my gauge, they're all automatically updating to use the appropriate domain and subdomain. Canventus WTA2 and Canventus WTA3. Okay? And so I can go into, and let me just actually go back here to one of these trend charts, and you can see that these are bound to WTA2, but it's deriving from script. Each of these has the appropriate calculation of the script binding pointing to the appropriate domain. And so when I go into run mode, I can clearly see that each of these controls functions separately from the others, and I can choose to show my trend graph, and the trend graphs, of course, are going to be different for each of these controls. So in this video, I've shown you how you can use the S# script capability built into DataHub WebView and combine that with dynamic point bindings to build a composite control that you can simply copy and paste and then update by changing the tags property of the group.